Today we are going to discuss about Descarte rule of sign. Descarte rule of sign is a method to determine the real root of a equation. Descarte rule of sign. Descarte rule of sign. Suppose we have a polynomial fx. If we equate the polynomial to 0, we will get the roots or 0 of the function. Suppose we have a function fn xn plus a n minus 1 x n minus 1 plus dot 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 plus a 1 x plus a naught. Okay, this is an analytic equation. If we equate this to 0, we will get the root of this function. Here f is a nth degree polynomial. Okay, this is an nth degree polynomial with all these coefficients are real, with real coefficient. Real coefficient. Then by Descartes rule of sign, we can determine the number of positive real root and number of negative real root. For that we will check it out. What will be the number of change of sign in fx and f of minus x? That is number of sign from when we move from this to this term, this to this term in fx. What will be the number of change of sign? Check out that one, and that will give you number of positive real root. And check out the number of change of sign when x is replaced by minus x. From when we move from this term to other, then that will give the number of negative real root. And the number of positive real root in fx is maximum is equal to the number of change of sign, and it will be less than 2 even integer. Okay, less by a even integer, because if it is not a positive real root or negative real root, then when it is complex root, and complex root occur in pairs, so it will be reduces by a even number. So right, the number of the number of number one the number of positive real roots are equal to number of change of sign in fx, or less than number of change of sign by an even integer, because complex root occur in pair. Okay, because complex root occur in pair, so the number of change of sign, number of positive root is less than number of change of sign by an even integer. Likewise, in right, the number of negative real roots are equal to number of change of sign in f of minus f, or less than number of change of sign by an even integer. Okay. Next, write a remark. Next, write a remark. If n is the number of change of sign in fx or minus fx, then number of positive or negative real roots will be n, n minus 2, n minus 4, n minus 6 goes on, etc. Okay. Here it is decreases by 2 because when it is neither positive root nor negative root, that means it is complex root. Then, and we know that complex root occur in pairs, so it will be decreases by 2. In the next lecture, we will solve some example. With that, I would like to conclude. Remaining will be in the next.